Hello everyone. Today I want to talk about different kind of optimization techniques that can be used in the neural network model as it is a important topic in the field of artificial intelligence and data science. So now I'm here to present an analysis on this topic. So as many of you already know that neural networks are cutting edge technology that has already changed many different fields. Neural networks have demonstrated their capacity to address intricate challenges ranging from image recognition and natural language processing to self driving vehicles and medical diagnosis. But these networks cannot reach their full potential until they are optimized. So, how do we make it happen? Now, let me show you some of the most important ways to optimize these models. One of the way to start is a learning rate. Now we have a learning rate parameter which changes the rate at which you learn as you generally train. So a well chosen learning rate can speed up the convergence and keep the system from going too far from the best answer. Now the learning rate is a critical factor that generally impacts the optimization process of a neural network. The learning rate has an influence and the magnitude of weight adjustments in the model during each update. The inquiry applies to the determination of an optimal learning rate. This depends on your problem space, the dataset, the network settings, like we generally use different kind of activation functions, complexity, regularization, optimizers. Now, what happens when we're using a higher learning rate? So, a higher learning rate can speed up the convergence, but it kind of risks of overshooting. While a lower learning rate may result in a smoother convergence, like you can see in the image here, like the big learning rate will be like, hey, where, here and there. But the small learning rate is like a taking one step at a time. Now, this can provide a convergence in a very smoother way. But the problem is finding the right learning rate or employing a learning rate scheduling is essential to effectively optimize our neural networks and achieve a better model performance. It generally requires a different kind of experimentations, intuition, and a good understanding of the problem domain and basically our data set. It's best to try out the settings, which are nearly zero point zero 0.01, and then make the changes based on how to validate the loss and the training loss, which is a change over the time. Now, also trying out different optimizers like ADAM or RMS prop, this can also change learning rate over time. One of the another way could be learning rate scheduler that generally slows down learning rate over time. Now the idea behind is that model gets closer to the global minimum and you want to fine tune its descent by making smaller weight changes. Next way is gradient descent, as we are already familiar with that. And in other words, generally what optimization means is like we are moving more towards the direction of velocity than towards the gradient at a certain point. Now, gradient descent is a fundamental optimization algorithm used to minimize the loss function. So the idea behind it is like by iteratively adjusting the weights and biases of a neural network, gradient descent helps the model approach the optimal set of parameters for accurate prediction. But to minimize or maximize the learning rate, we can add another parameter that is the momentum. Now, momentum is an extension to the gradient descent optimization algorithm that allows the search to build inertia in a direction in the search space and overcome the oscillation of noisy gradients and generally coast across the flat spots of the search space. So by adding SGD with a momentum, we can add kind of accelerate one kind of way to start, learning more. Now, another way is this is one of the code sample I have provided, like how we can, implement momentum with a SGD. So another technique could be using again Nag optimization. This is another technique that's generally used to optimize our models. This is one of the example I provided. Like if you can see in the left corner, the counters of a loss surface and time evolution of different optimization algorithm. So if you see the overshooting behavior of the momentum based on different methods, which make the optimization look like a ball rolling down the hill. Now, in the right side, the visualization of a saddle point in the optimization landscape, where the curvature along different dimensions that has different signs, like one dimension curves, and it's kind of going up, and the another one is down. If you see, the SGD has a very hard time breaking symmetry, and it kind of gets stuck on the top. Conversely, the algorithms such as RMS prop will you'll see it's very low gradients in the saddle direction. Now, due to the denominator term in the RMS prop update, this will increase the effective learning rate along with the direction. Now, helping RMS prop generally proceed with. So if you see totally in both of these graphs, I would say, in conclusion, we can say optimizing neural networks is generally a complicated and interesting process that needs a careful balance of math, intuition sometimes, and experimentation. Now, by using the right optimization method, we can unlock the full power of these amazing models and see how they can be used to solve problems in the real world. So that's it. Let's learn the art of optimization and dive into the interesting world of neural network where innovation has no limits, and let's work together to pave the way for a future where smart machines will change the world for many years to come, I guess. I will add more optimization algorithms and explanation with different kind of Python codes for different kind of problem sets. I hope that would be helpful to you and me as well. Thank you so much.